Ah, welcome back. Happy Monday. I took some time and read some of the feedback that you guys were giving me on how this was going, and I do understand that there is some frustration, but I feel like the general consensus is if I clearly explain something, you guys don't mind doing a little bit of math about it. So that's how this is going to work. A lot of people also expressed frustration in the physical process of taking pictures and sending them in and how challenging that was. So we're going to try something different. We're going to have math questions on this, but it's going to be submitted as a Google form. So you can do all the work on scratch paper at home and then just click the buttons to submit your answers. And let's see if this helps. Just make the whole process a little bit easier, cut out some time of the uploading and all of that. So we'll see how this goes, and we will try this in the last week before break. So, getting started. Now that we've finished talking about Newton's three laws, it's time to kind of get into a practical application of them. Work and power are some of the most fundamental concepts of physics. And you need to understand what these things are before we hit the very last, most important unit of this class, which is energy. So work and power. And what you see is a picture on the screen of a weightlifter. And this is perhaps the single greatest example I could give you of what work is. Work is just moving objects over a distance. So as the weightlifter lifts the weight up and down, what he is technically doing is work. Work is defined as a force exerted over a distance. W equals Fd. So when I say W, that W stands for work. Work equals force times distance. That's what that means. Work equals force times distance. So anytime you push on something and it moves, you're doing work. So when you're pushing your body along the floor and you are moving, you're doing work. You lift the backpack up and put it on your shoulders, you're doing work. You lift the calculator off the desk, you're doing work. But work is only done if an object moves. So if you look at the nearest wall and you decide to push it, and the wall doesn't move, you're not doing work. No work is being done to that wall, because in order to do work, there must be movement. Work is defined as movement. So if I push the wall, and the wall doesn't move, but I move back, I don't do any work to the wall. Rather, the wall does work to me, because I'm the one who ends up moving. The wall's working me. So, work is measured in a unit called joules. This Joule is pronounced joule. Joule. That is the scientific unit for both work and energy. I'm sure you've heard of joules in your other science classes, but this is where joules are going to come to play in physics. So, okay, simple equation. Work equals force times distance. Work is done if the object moves. So how much work is done when a 50 Newton force is exerted over 5 meters? Okay, let's do this. We're looking for work. We have a force. We have a distance. We multiply it out. So we could say that work equals 50 times 5, or 250 joules. Simple. So we have seen triangles before. It's just going to be another triangle. This is not the hardest thing we have done. I am confident that you can figure this out. So this is going to be the WFD triangle. The WFD triangle. So I'm going to read through these 3 sample problems, and I'm going to do them out. Feel free to follow along, and I'll show you how this is going to work. Work. All right. what is the work done? Okay, so we're looking for work in the first question. So work equals question mark. If a 14 Newton chair, okay, 14 newtons, 14 newtons. 14 newtons. I remember newtons is a force. I feel like we just did a whole unit on Newton's laws and forces. Is lifted 1.5 meters. Meters. Well, meters has always been a distance, all right? So 1.5 meters is the distance. Yes. W. F. D. So we know the force is 14. So we're going to put the 14 right here. We know that the distance is 1.5. When, on the triangle, when you have the two bottom parts, you multiply them. 14 times 1.5 is 21. And the unit for work is joules. There you go. That's it. 21 joules. Simple. 14 times 1.5. That's it. Let's look at the next one. What force? Force. So we're looking for force this time. Okay? Force equals question mark. 28J. Okay, J. Oh, I know. 28J is work. So I'm going to say that the W equals 28J. 2 meters. Oh, 2 meters is a distance. So distance equals 2 meters. Oh, okay. This isn't that bad. We're going to use the triangle again. So work is 28, so I'm going to put 28 up here. The force is what we're looking for. And the distance is going to go right here. Awesome. So we're going to divide 28 divided by 2. So force equals 14 newtons. That's it. Okay. So when it says what force, that means we're looking for the force. When it says what is the work, that means we're looking for the work. How far? Oh, this is taking me back. When something says how far, that means you're looking for distance. Okay? So we're looking for a distance. 36 newtons. Okay, so 36 newtons is a force. Force is 36 newtons. 108 joules. Okay, joules is that new unit. That's got to be the work. And it is. And we are looking for the distance. So, simple. We use the triangle. When looking for the distance, we are going to divide 108 divided by 36, and that would give you the distance. What is 108 divided by 36? Why, that's 3. 3 meters. So what this is this is a triangle, as we've seen many times throughout the year. Power. Power, so if work is simply moving an object, power is how fast you move that object. Okay, let's talk about this. If you lift a book, it doesn't matter how fast you lift it. You do the same work. What do I mean by that? Well, let's think about it this way. If you walk up a flight of stairs, or if you run up a flight of stairs, you go up the same distance. But you're more tired if you run because you've used more power. You've done it in less time. So you have done the same amount of work in either situation. So if you're lifting weights, if you are, lifting a 45-pound weight, whether you lift it quickly or slowly, you do the same work. But if you lift it quickly, you do more power. Okay? If you've ever been to the Science Museum and they have that little crank connected to the light bulb, and you turn it and then the light bulb lights up, and the faster you turn it, the brighter it goes. That's the same concept. The speed in which you do it is going to determine how much power it takes. And if you notice, the unit for power is watt. Where have you seen that before? Light bulbs are perhaps the most common answer. If you've ever replaced a light bulb in your house, you might notice that there is a certain wattage on it, 60 watts, 100 watts. I don't know what type of light bulbs you guys use, but they do have watts in them. So this is going to connect to electricity, which is the very, very last thing that we're going to learn this year. So this is how it's all bridging together. Power is measured in watts. So power is how fast you do work. Work is moving something. Power is how fast you move it. So the equation for power is this: W equals P times T, or work equals power times time. Okay. So it says, how much power is produced when 60 joules of work is done in 3 seconds? Now this is going to be a little bit tricky, but you know what? I can turn this into a triangle too. Just like before, we're now going to have a second triangle. So we have 2 triangles going on right now. We have the work, force, distance triangle, the one we just practiced. We have the WFD, and now we have the WPT. And you're going to see how this is going to work in just a second. So if I'm asking for how much power, now we're looking for power. That's the P. 60J, J is still the unit for work. And T is, of course, time, which is seconds. So let's see how this is going to work. But exactly, the work is 60, the time is 3. We divide it, so we have a power of 20 watts. Okay, let's do a little bit of practice on this, just to make sure we're good. The reason I want to practice with this is because the units here are a little bit tricky. What do you mean by that? Well, let's keep the units straight. So we have the WPT. All right, so number 1, how much work? We are looking for work. Work is question mark. Does a 120 watt bulb? Oh, okay. This is why it's tricky. When I see 120 W, this W right here does not stand for work. When you read it in a problem, the W stands for watt, which is the unit for power. This is why it's tricky. So when I see W in a question as a unit, that means watt, which is power. When I see W in the triangle, it means work. So W has 2 different meanings. W in the problem means watt. So if I'm reading a question and I see a W, that means watt. But when I look at the triangles, that W means work. This is why it gets tricky, but nothing you can't figure out. So work equals what we're looking for. Power is 120, and 3 seconds, time, is 3 seconds. Okay, so when we're looking for work, we're still going to use the triangle just like we've done before. We have a WPT. Okay, so the power is 120. The time is 3. So the work, we're just going to multiply those numbers, and that's going to be 360 joules. Work is multiply. Work is multiply. Okay. Now, how much power? Number 2. How much power? Now we're looking for power. So P equals question mark. P equals question mark. Do you use when you run up the stairs with 1,200 joules? Okay, when I see joules, 1,200 joules, that is the work. Joules is work. So joules is the W in the triangle. And 4 seconds. 4 seconds is, of course, a time. I think we knew that. Okay, great. So we're looking for the power, and we have the W and the T. Triangle time. The W is 1200. The power is what we're looking for, and the time is 4. When we divide that out, the power is going to be 300, and the unit for power is watts. W. 300 W. Okay. Lastly, how long? Now this is taking us back. When it says how long, that means we're looking for time. So T equals question mark. T equals question mark. Will it take to get 60 W? When I'm reading a problem and it says 60 W, I know that means watts. And watts is the unit for power. And 30 J of work, well, joules is measuring work. That's it. That's it. Plug it into the triangle. So work goes up top, 30. The power is 60. The time is what we're looking for. 30 divided by 60 is 0.5 seconds. Okay. So it's just a triangle. A little bit of tricky units, but it's just a triangle. Now, this slide is going to really help. I don't know if you guys are taking notes on this or not, or you're just kind of watching this and following along. But on the left, it says quantity. These are the symbols in the triangles. So if you're looking at the symbols in the triangles, so we're talking the W, F, D, and the W, P, T. So when we're talking about these little triangles here, okay, we're talking about these symbols up here. So when I see the W in the triangle, that means work. But if I'm reading a problem, read in problem, and I see a number, and that number is followed by one of the units here, that would be these. So what do you mean by that? So if I see a problem and a problem says 30 joules, I know joules is the unit for work. So that means the 30 joules would go in for the W of the triangle. Okay? So if I read a problem and it says 4 newtons, newtons is the unit for force. So that means the 4 newtons would go in for the force on the triangle. Meter is the unit for distance. So if I see a problem and it says meters, it's going to go in for the D on the triangle. Watts, if I am reading a problem and it says 60 watts, 60 W, because I'm reading in a problem and this W is next to the number, I know it's a watt. And this watt really stands for power in the triangles. I know it's tricky because there is a W here and a W here. But when you see the W in the triangle, it stands for work. When you're reading a problem, it stands for watts. And seconds is the time. So this is the list of units. So when I see the unit for work is joule, the unit for force is newton, the unit for distance is meter, the unit for power is watt, the unit for time is seconds. So as I'm reading a problem, the units appear in problems. So if I see 30 J, I know that means work. That's why these arrows kind of go back and forth. I need you to understand how these things connect, that the units measure these quantities. So, quick recap. That's all the math that we're going to do. We have 2 triangles. But I want to explain something. Work is only done if you move. However, that doesn't mean you can't get tired by not doing work. So I said a weightlifter is the best example I could think of as work. So let's picture if this weightlifter is holding this weight over his head. He's just holding it. He's just still. Because it's motionless, because it's not moving, at that time, he's not doing work. But that doesn't mean that he can hold it up forever. Because even though he's not doing work, his arms are still exerting a force. That force is holding it up against gravity. So even though he's not doing work, his arms are still going to get tired. And if he lets go of it, then that barbell would be then doing work to the guy's head and moving it a distance. But as it's still over his head, there is no work happening. And again, the difference between work and power. You got little Susie and Nellie Newton. If they have the exact same mass, the same weight. If Susie walks up the stairs and Nellie runs up the stairs, both did the same work because they went the same distance and they have the same masses. But who did more power? Nellie exerted more power because she did the same work in the less time. If you do something quicker, you have more power. I don't want to confuse it too much, but we could say that power and time are inversely proportional. If you do something in less time, you'll have more power, and vice versa. So, that's it. We have 2 new equation triangles. All the units are listed there. If you have any confusion, if you have any thoughts, if you have any concerns, if you don't know what to do, please, please, please email me. I am here to help. This is due tomorrow night. You have plenty of time to get this done. And if not, again, email me. I hope you all saw the email I sent out last Friday. I really want you guys to be able to do this. I know it's frustrating to learn things on your own, but I know you all have the ability to do this. I am here. Please email me. Good luck, and I will talk to you guys on Wednesday.